Hi, Sean here, and today I would like to show you my custom occlusion engine that I've built in Unreal Engine 4 using blueprints. And so the way this works is it leverages Wwise at the moment to do the audio processing, although all it does really is spit out data, so I can't see why you wouldn't be able to use FMAD or perhaps even Unreal's own audio engine to do the actual audio processing, but I'm just using Wwise at the moment because that's what I prefer. So to start off with, I'd like to just do a little demonstration. So we have this audio object here. If we jump in, you'll hear that it's just a kind of general windy day ambience that I recorded. I chose this because it's a nice broad spectrum noise that'll show off the filtering and attenuation quite nicely. So this ray trace goes from the audio object to the character, and when objects get in the way, we get some data about those objects, and then that's applied to the audio. So you'll see in the top left there we have a filter amount and a volume attenuation amount, and these values for demonstration purposes go between 0 and 100. If you wanted to maybe change filter amount to be like a frequency, a number between 20 and 20k, you could do that. Volume attenuation, whatever numbers make sense to you, but for the purposes of demonstration and making this easy, I've gone with 0 and 100. So we have two different objects here. One is like a brick wall type thing, and another one is more of a kind of rock face. So if we go behind our rock face object, you'll hear some quite heavy filtering going on there. Filter amount is set to 60 and volume attenuation is at 50. And then if we go over to our brick wall, much more subtle. Filter amount is 30 and volume attenuation is also 30. And you can see this, so it distinguishes between objects based on their physical materials. And this effect also stacks. So as far as volume attenuation goes, the values are just added up until you reach your max amount, at which point it's the sound is completely gone. And for filtering amount, it chooses the max filter that will be applied for any one of the objects it hits, and then applies that. So you can see here we have 60 and 50. And you can see here volume attenuation for those two objects, 50 plus 50 being 100. And the filter amount is still 60 because it's just chosen the max one. And you can see here it also can stack different physical materials too. So there you go, 30 and 30. And now it's barely audible, you got 60 and 80. So you can see how this works now. And I think the best way to demonstrate it really is to just make a new physical material and throw that into the engine and get that to work. So to start off with, this whole thing is done through Blueprint Function Library, which means then you can just open that up and use it within any of the blueprints that you have in your project. This is the occlusion engine here. It's pretty long. I'm not going to go into detail about all of it, but if you do have any questions, shoot me an email, get me on Twitter. I'm happy to explain and share this with anyone who wants to implement it in one of their projects. So we'll start off by making a new object. So what we want to do is make a new physical material to apply our values to. So if I was going to my physical materials folder here and make a new one, and we'll call this test 3. And what we want to do is apply this to some sort of material in game. So let's go with this stucco type material here. And this might take a little while for me to apply. Test 3 there. So I might have to cut away. Alright, it's saved that now. My computer takes forever when it's saving materials, but there we go. So now we have our new material and we have our physical material applied to it. So how do we get that into our audio occlusion engine? Well, the way that data is pulled into the audio occlusion engine is, first of all, we have this actor here. And what this does is it sets arrays which can then be accessed by any blueprint that you like within your project. And you make one instance of that in your level. My one lives over here. That's him there. And it doesn't matter where you put it, as long as there's one in the level, you'll be able to access this data from anywhere. And that data is pulled from this physical material set, and that is in our function library. So what this does is it takes a data table, which we'll get into in a moment, and for each row in that data table, it breaks out the custom struct out into its constituent parts and makes an array for each one of those that you can then access further down the line, and returns those. So in that custom struct, we have the physical material, its attenuation amount, and its low pass. So yeah, so in one end you have your data table, at the other end you have all of the information you need to feed into the occlusion blueprint. So the next step would be to update our data table. Quickest and easiest way I've found to do this is just to make a little CSV file. So I have test 1 and test 2 already in there. Let's make test 3. Okay, and the physical material references can get a little lengthy sometimes. It takes the folder architecture and throws it in there. So let's just copy and paste that one out and change this to test 3. There we go, nice and easy. And we'll put this attenuation and low pass to values that are distinguished from the other one so we can test it easily. So let's go for 10 for the attenuation and 40 for the low pass. So we have some new values in there. Let's save that and close. Yeah, it's already saved. And then when we go back into Unreal, we want to re-import that CSV file and override the current data table. Yes. Save that. So now that's automatically fed all that data straight into our occlusion and diffraction engine. Because you can see event begin play, it takes all of the objects in the data table and then makes an array out of them. So we have our data there ready to go. So how do we implement it on our audio? Well, we can do this on a per object basis. So for the moment I've done this in the blueprint for our AK audio object here. So if I just find the blueprint for this, you'll see that the occlusion is one of the objects here. There's also this, but this is just an attenuation thing that I was messing around with. Just ignore that for now. So every tick, we check for occlusion. And then event begin play, we get the data from our data actor and pump that in. So that's set once, and then that's it. So for the occlusion engine, there's like a fair few inputs. I'll go through them quickly now. So we have the audio emitter, which is itself. If you wanted to have the blueprint operate outside of the audio emitter's own blueprint, you could, this facilitates that. If you wanted to maybe organize it a bit differently, I don't know. Player index, which just affects which player the audio is aimed at, and then draw debug type. This is just so we can see the line traces. We can turn those on and off. Character head offset is so that you can have the line trace actually go to the character's head rather than maybe their hip, where the actual kind of root for the XY component would be on that character. So it allows you to trace to the actual mesh's head rather than anywhere else. If you tick listen from camera, the ray trace will be done to the camera instead of to the character mesh. So this might be useful for things like first-person shooters, or if you just want to listen from the camera rather than the actual player. And then we input our physical materials list and the volume attenuation and the filter arrays that we have set earlier on. This max check radius just simply checks for the amount of space between the player and the audio object, and if it's above this amount, then none of these checks are done, and that saves on CPU. So if you have multiple objects in your level, you can set radiuses that will allow you to kind of save on CPU and not be checking for these things constantly. Then we have the names of the RTPC values that we want to change in Wwise, and some debug. Just if you want to print different hits, whether it's muted, etc. So about that, I'm back. Yep. So let's put that actor into our level. I have some test meshes here that I'll just edit one up, and we'll apply our stucco material to this. Let's go stucco. And again, it has two faces because why not? That's ready to push in now. Let's pop that into our level. Get it actually on the floor. There we go. Let's just replace this one here. Get it all lined up and looking nice. Right. So now if we drop into our level, you'll see that we have 30-30, 50-60, those values work correctly. And then 40 and 10, our values we set earlier on. And it's that easy just to put new physical materials into the engine. And if you want to tweak or edit any values for your current physical materials, it's as easy as just editing the CSV file and then throwing that in. It's done. That's it. Once the material is set up, editing it is pretty damn easy. And that about wraps it up for now. Hopefully soon I'll be showing off the diffraction engine that I'm using to complement this. The transitions between occluded and unoccluded are quite sharp, although there is no interpolation on that at the moment. So if you wanted to interpolate, you could smooth that off a bit, but I think diffraction is a better idea anyway to get around that. Hopefully I'll also soon be showing off autosave, thank you. Yeah, hopefully soon I'll be showing off a live early reflections engine that's geometry based. The blueprint's ready. I'm just trying to package a custom plugin for Wwise that'll handle that properly and use it properly. That's the blueprint there, and I'll make that available at some point and demo that. But yeah, again, if you have any questions about this, then please just send me an email or get me on Twitter. And yeah, have a nice day.